Thanks everyone for asking me to present what we have done at Sky. I'm going to present how we have been using Machine Controller Manager and autoscaler at Sky. So we are not using Gardener, the full project with the control plane, but only MCM and autoscaler for now. And we might in the future embrace the full control plane and Gardener project. So just before starting, so please, if you are interested, join the community, and you've got like a few ways to join the community with like GitHubs that are quite responsive. So yeah, go for it. Just I'm gonna introduce myself a bit more. So I'm Anthony Comtois. I'm French. I've been moving to UK like 5 years ago, and I'm working for Sky as a principal engineer. So we manage mainly a streaming platform, a video platform, which is across Europe and also available in USA. So we've got a big part of USA, which is under Comcast and Peacock TV, which has been launched last year. And in Europe, it's mainly Sky, and we're available in UK, Spain, Italy, and I think Germany too. So in terms of, so I've been using for the last 4 or 5 years Kubernetes. So it was like quite early stage. I've been using Mesos before, and then we switched to Kubernetes when I came to Sky. So it was quite early days, and we've got like trying to debug a few stuff to make it production ready, and now it's getting way smoother. In terms of scaling figures, so we are managing between 20 and 30 Kubernetes cluster in USA and Europe. We are multi-region and mainly on AWS, and we are potentially investigating multiple other providers like GCP or Azure, to be a bit more resilient. And everything is fronted by a CDN, and then we can load balance to multiple Kubernetes cluster. We tend to do not choose too much. We prefer having like fewer Kubernetes cluster because that's easier to manage, and then grow the number of applications which are hosted on the platform. Our biggest cluster is around 500 nodes, and we are spread across multiple AZ to avoid any failure or single point of failure. And we currently, so the platform is used by 100 teams, which is about 1,000 engineers which are pushing daily to our platform. So we've got a path support or a pipeline, the continuous pipeline delivery, which gonna deliver every day. And we've been testing our ingresses for 1 million TPS through the ingress per ingress and per ingress. And yeah, we are hiring. So if people are interested to work for this kind of scale, yeah, you are welcome. So in terms of the existing infrastructure, so we wanted to move to a bit more immutable infrastructure and having like a easier way to scale. So at the beginning, we were using a Kubernetes cluster, which has been managed mainly by Terraform to spinning up the instances, autoscaling group, and network side of things. And we were provisioning with Ansible. And we were using a promotion mechanism from dev stage and prod and so on to make sure we check the alert before going to deploy the new version to the new environment every day. We've been using mainly an autoscaling group, which we're spinning up an Ubuntu AMI with a few changes, but very little, like was like SSH key but very little. And at startup, when it was running, the VM was running, then we were installing everything, the packages, and joining the cluster, which obviously is not ideal because you cannot scale like very fast. You've got like some limitation, and we knew about it, but it was just for legacy reasons why it was like that. So we wanted to, our goals was to reduce the provisioning time from, it was around 20 minutes to 30 minutes. And we wanted to have like a provisioning time under 3-4 minutes, and at the end of it was like close to 2 minutes, which allow us to have like a better dynamic scaling and we wanted also to avoid incremental changes from one environment to the other one. So just deploying a new AMI rather than applying some Ansible on top of an existing VM. Because from one environment to the other one, you've got a different environment variable which change, and then it can be misleading. And we wanted to use like a Kubernetes native solution, like via an operator and TRD would be our preference. So you've got what should we use? We put like a few options. You could at this time. So we've been starting to last year to do the migration. We've got a couple of options because now you've got like the self-managed Kubernetes like EKS or GKE, which are available and starting to be quite production ready. However, every time we've checked, we were feeling like we were losing a bit of flexibility. Like you've got some restriction for the API server that you cannot configure everything. So you've got the OAuth login, which has been some issue on EKS, and mainly about routing and CNI. You don't fully control the CNI you are putting in place, and that can be sometimes limiting, like especially on GKE. Been like trying to do at some point. I mean, we wanted to have like cross-cluster communication from pod to pod, and so you've got different overlay like Calico, which can be used to do that, but on top of GK, it's quite hard because they manage essentially the network. So you don't know, even if you install one Calico on top of it, you don't know what's going to happen when they just change it. So it was quite flaky. So that's not ideal. We might want to use it in the long term, but for now it wasn't. It wasn't the solution we available for us. And also the migration would have been harder because we have an existing cluster. That means we would need to create a new cluster and ask the team to move over, which is potentially quite more work than just replacing our current node setup. We've been like investigating cluster-API, which has been sounded really promising. And at this time, like a year and a half ago, it was not production ready. We were thinking to contribute to it, and due to delivery time and delivery pressure, we just like thought it would have been easier to just create our own operator just to manage a node. And we didn't find machine controller at this time. So we started to create our own operator. So we've seen a few operators which were aiming to manage a node, and it was not working as we wanted to. So we've started to create our own with essentially creating autoscaling group and using spin up a new AMI through this autoscaling group and tear down the other one. And at some point we were working on it. It was going smoothly with the development, but at some point I just found a machine controller manager, and I mean, it was working pretty much. So I've been doing a POC, and it was pretty much working out of the box, except a few things we wanted to improve, like allowing multiple disk and security groups on the machine deployment, which gonna attach to the VM. So I've been raising the PR, and it has been like nice feedback and merge on master. And so we decided to go for it and try to migrate all our infrastructure to machine controller manager. And I've been like doing the full POC with also including Gardener autoscaler. And there were a few stuff which wasn't working. One of them was because we've got existing MCM, non-NCM node, so legacy node. MCM autoscaler was trying to find the machine deployment related to this node, and he couldn't scale down the VM. So we have created a PR to skip it. And also I find it, we don't need it right now, but it would have been nice to have a machine deployment allow to be set to 0, and then allowing us to scale. And to do that with a autoscaler, you need to create a virtual node. Then it's going to know about the CPU and memory, and for scheduling reason, it's going to be able to spin up to choose the right machine deployment to scale. Which is, I think, in progress. It's kind of working for AWS and Azure, but not for everything. And I think there is a few issues to raise on the Gardener or machine controller manager side to be more agnostic, provider agnostic, to have the definition of the CPU and memory potentially on the machine deployment. But that's something I guess it needs to be discussed. And yeah, another one that's we've got a PR from one of my colleagues to sometimes we've got like a insufficient capacity error on AWS, so which means they basically do not have this kind of instance type at the time. And we were trying to skip this machine deployment or node pool and set it as unhealthy or lower the priority of this machine deployment to make sure you can scale with other type of machine deployment. So because we've got an existing architecture with existing API server, we wanted to, for now, keep using this API server strategy. And so we've been implementing multiple pipelines to make sure we can use machine controller manager and autoscaler. Through those pipelines, so we've got usual pipeline with what we call a pass to prod, so going to production, and we run some integration tests, functional tests, NFT for each of those components. And so those 5 items are mainly the pipeline. We've got a pipeline for each, which is the first one is the creation of the AMI, so it's mainly Packer and Ansible. We're gonna install most of the component, kubelet, DNS mask, and what we need for the node, and gonna release an AMI. Then we've got the node configurator, which is essentially a Docker image with a few Ansible inside, which is going to be downloaded. So the Docker image is going to be produced and going to be downloaded at startup from the VM. So when MCM start a node with this AMI, it's going to download this Docker image, and this Docker image will run some Ansible, essentially to format some disk and configure based on the environment, like DNS, and based on the tag of the AMI of the node, it's going to configure kubelet config and things like that, and get the token from the API server to register to be able to join the cluster. We've got another pipeline, which is machine controller manager, which is essentially deploying MCM across all the environment, and we have integration testing to make sure we can spin up some instances on our infrastructure and through MCM. Machine deployment pipeline, which is essentially just creating machine deployment on top of all our environment. And we are working on autoscaler, so we've done a POC. We're not so right now we are in production. We're using machine controller manager. The autoscaler is not yet deployed in production, and we are using it for testing purpose and making sure the integration test is going to be okay. It's mainly relying on per disruption budget, and we want to have OPA, Open Policy Agent, to block the tenant to be able to define a per disruption budget, which is going to be blocking MCM for during a rollout, with a maximum available, for example, to 100% or to 0% actually. And we've been testing with over provisioning, so having essentially a deployment with a post container which does nothing, and we've got I think it's a node proportional autoscaler, which is going to set the number of replica for this deployment based on the number of node. And so more you go, more you have, like let's say 20% of room to be able to scale. If you have a huge spike, you will be able to spin up more deployment replica before scaling the cluster. And with the priority preemption, so the post container is going to be evicted. The actual deployment from the team are going to be scheduled. And then that's going to be up to autoscaler to say, well, still have some post container waiting on the queue. So I need to spin up or update machine deployment to spin up some node, which is working quite nicely. In terms of lifecycle and management, so we've been like trying, making sure we have like the right pipeline and the right amount of testing to make sure we can automate and deliver every single component one by one through the pipeline. And so we are checking after the integration test, NFT and functional test. We are promoting every day from one environment to the other one by checking any alert from Prometheus. And so far, yeah, it's what we have been doing for every single component. One thing which has been like a bit, at some point, when you do rolling deployment and you change, for example, the AMI, MCM is gonna spin up some new node and it's gonna wait for the node to be ready. So it's checking if node ready is equals to true and all the node conditions are set to false. And we wanted to do a bit more check because it doesn't mean much to us. I mean, sometimes it's just, yeah, it's ready, but you don't have all the required daemon sets. So we've been like building and DNS connectivity. So we've been like building a specific thing into node configurator, which gonna at startup set the node initializing to true, which is gonna essentially block MCM to see the node as ready. Then we check if you have like DNS connectivity, kubeproxy routing. So if you can resolve Kubernetes DNS, then you have kubeproxy working and the routing is working. And we check also if like we have the required daemon set like log shipping, network policies like Cilium up and running before setting up to false for the node condition, and then which gonna allow MCM to carry on and see the node as ready and spin up a new node if it does a rolling deployment. So that's an interesting feature. I'm not too sure if Gardener project actually is using it like that. And then we've got another issue, which is the insufficient instance capacity. So during a rolling deployment, sometimes AWS doesn't have the instance type or run out of this instance type. So we've been like, MCM has been stuck. It doesn't affect anything, but for our rollout, it takes, it can take longer. Like sometimes it wasn't available for 6 hours. So you've got MCM, which is trying to redeploy, but it cannot. So that doesn't impact anything, but it would be like nicer to have a smooth rolling deployment at every single time. So there is a few idea we are investigating. So the first one, which is you can pre-request some resources on AWS to make sure you have like the required number of resources, but you have to pay for it. So you're gonna pay for those instances you are not using it. So it's not that nice and it's tedious. That doesn't work with auto scaling. You're not gonna request pre-resource every time. Another way is to diversify the instance type. So you could have different machine deployment with different instance type, and MCM should or autoscaler should pick one of them, which is not which are available. And another one, so we've been talking with AWS, and at some point they were talking about a method I don't remember, but you can, rather than using run instances through MCM, which gonna spin up the instances, you can use another method, and in theory you can provide an instance type list. So you could have like all the M5 and C5 or whatever, and give the full list, and hopefully it's gonna be able to check one of them or spin up one of them. So that would be a possibility, an option, but we haven't worked too much on it right now. But yeah, that might be something we want to at least discuss with Gardener and see what would be the best way. We've been testing, so we've been seeing a spot instances feature, which is quite nice. We've been testing it as a POC. It seems to work as expected. maybe we haven't tested it potentially with the autoscaler. We don't know if you run out of spot instances, would it fall back on the on-demand deployment? So if you've got two machine deployment, one specific for spot instances and the other one for machine deployment on demand, then hopefully if you don't have the capacity, it should fall back to on demand, but I'm not sure. I've been testing it right now. So as a conclusion, we are pretty happy with MCM and Gardener autoscaler. We are happy to contribute if we miss something, but for now it has been pretty smooth. The migration has been really easy. Basically deploying MCM, speeding up new machine deployment, and then tearing down the old node. So it has been great because it was easier than creating our own operator, which kind of have like, obviously you need to improve the testing every time you create a new software. So it's nice, it has been already tested quite nicely. And it has been allowing us to move to a more immutable infrastructure approach with replacing all the node and allowing us to keep the control plane, which was quite nice because otherwise the migration would have been harder. We might want to use the full project Gardener with the control plane in the long term, but for now we need more investigation on how we can migrate. Essentially, it would be potentially take a backup of etcd, spin it up the new Gardener control plane, and import the data and switch over for the API server for on every single node. But yeah, that's something which need to be tested a bit more. And yeah, so far very happy with MCM and autoscaler. That's it for me. Thank you.
Great. Thanks for the nice talk. Do we have questions?
So hi, Anthony. Yeah, I saw your presentation. Nice presentation. Thanks. So yeah, one point regarding the scale to zero, like Vedran was going to mention, we also have worked on something like this. And if you see the implementation currently, I think it should support scale to zero, even with the autoscaler. Have you tried it of late?
I've been trying like maybe a year ago with AWS. It was working with my change, but yeah, I've seen a few changes from your side. I haven't tested it.
Yeah, I mean, our changes. It was also, I think, contributed from one of the external colleagues.
I think it was Anthony himself.
Huh?
I think Anthony himself contributed.
Yes.
Yeah, so I did it, but only for AWS and Azure. And we need to have a generic way to create the virtual node. And there were some question about setting up the CPU and memory or instance type on machine deployment itself, and then you don't have to change the autoscaler code, and it's just going to be generated. It's going to get the information, CPU and memory from the machine deployment, and we'll be able to discover and build the virtual node.
Okay. Yeah, I remember now. Okay.
It was pretty much also what we wanted to implement, but we so the reason we haven't yet is we wanted to finish our machine controller manager out of tree implementation. So right now it's all in tree, and after out of tree, actually we wanted to pick up the scale to zero in a more clean way, in the sense, as you also suggested. I mean, we have the information in the cloud profile. We just need to propagate them, and then solution is easier.
Yeah.
Yes. And Anthony, have you had a chance to look at the out of tree as well?
Yeah, that's something I haven't been looking for. For now, we are just using it without. I mean, I've seen a few PR, and I've checked the code for the out of tree. Sounds nice. We're not using it right now. Is it like ready to use, or?
Yeah, so I think we'll come up with probably a presentation in the upcoming community meetings. And yeah, it's almost, I mean, we have started using it internally with one of the providers. We are migrating it for the others. Seems ready. Maybe we'll come up with it in the upcoming community meetings with it. presentation on. Yeah. Thanks.
So Prashant, you're welcome to add that directly to the slides, and you'll be very happy. I think for next 4 weeks there are no proposals yet, so you can jump in there for a week.
Yeah, sure, Anthony. I think we were planning for this week, but it got delayed with some other things. But yeah, maybe coming weeks we will. Me and Samar together, we have a plan. Thanks.
Yeah, hi, Anthony. This is Vasu. Thank you for your insights. Now, I have a question. Is the machine controller manager the only component you're using from Gardener? I mean, we've got some other components which are quite versatile, like the backup restore or the external DNS manager. Are these components you've also taken a look at, or are they just an open question?
Yeah, so we're only using MCM and autoscaler, but I've been checking you've got the etcd backup and restore project, which sounded really interesting. Especially at some point we are using our custom etcd for the API server, but also we have a dedicated etcd for Cilium, and we wanted to have like sharing, having a single software which is gonna do the backup for etcd. We are not using it right now. We might use it in the future, but yeah, that's something we could look into it. And yes, the other one, yes, the external DNS. I've seen it briefly, but I haven't checked much.
Okay. Yeah, interesting. Well, looking forward for some new adoption. And one more question. I think that you're basically also reutilizing the upstream Kubernetes binaries or distribution, if you will, that is released by the Kubernetes project itself, and you're not using I don't know, EKSD or another type of distribution. Is that assumption correct?
Yeah, that's right. Yeah, we're using the plain Kubernetes, and everything has been like, so installing through Ansible, but yeah, everything is from the Kubernetes binary, and we don't have any. Yeah.
And the follow-up on that is, do you do security scanning of these binaries and whatever you put in production? I assume yes. Is there any type of work which could be shareable, right? When you find security problems or things like that, that we have kind of a could establish a cooperation or collaboration, that if you fix something or find something that we inform each other. Is that something of interest?
Yeah, definitely. Yeah, we could. For now, the security side is mostly with proprietary tools like Qualys, Nessus, and a few other one, Twistlock. But yeah, definitely we could contribute if we find some vulnerabilities. I would be more interested to have like also some open source project like security wise. I've seen a few stuff like Falco and other project which can be interesting. Yeah.
Okay. Yep. Thank you. Just thinking out of the box. Okay.